This is lesson 2.2. It'll be the first video of many, and this is 2.2a, trigonometric functions of non-acute angles. And I alluded to this concept back in chapter 1, and hopefully if it was a little bit confusing for you back then, I can make it less confusing in this lesson. Okay, so for every non-quadrantal angle in standard position. A quadrantal, if you remember right, is a 90, 180, 270, or 360 degree angle. So we're not talking about those. We're talking about all the other angles. In standard position, meaning that one of the lines is on the x-axis, like that. So every angle that has as an initial line or initial side on that positive x-axis, and we draw it like that, we have what's called a reference angle. So when we're talking about anything less than 90 degrees, the reference angle is basically non-existent. It's I guess for lack of a better word, it's its own angle. So we don't need a reference angle in the first quadrant. Now, a reference angle is always less than 90 degrees. Well, this angle here is less than 90 degrees, so it ends up being our reference angle to itself. But when we get over into some of these other quadrants, such as over here, and let's say that this angle right there is a 130, well, 130, come on, 135 degree angle, my reference angle would be a vertical line connecting to my x-axis with a 90 degree angle there at my connection point. Okay? That angle is my reference angle. In this case, it's a 45 degree angle. So I can do all of my trig functions with this angle and not worry about the 135, because the answers that I get for my reference angle are going to be the answers for my 135 degree angle. So if I took the sine of 45, it's going to be the same as the sine of 135. So I can just ignore everything else and just look at this reference angle to do all of my work, and my answer will transfer to this one. So if you take your calculator and type in there the sine of 135, see if it's the same as your sine of 45. Okay, let's look in the third quadrant. Let's say we have a line right there, and this went all the way over to there. And let's say that this is a 250 degree angle. Well, all I have to do is draw a line right like that. Well, in fact, now let's keep that there. Let's erase this. Draw that 90 degree angle. This angle here, if this is 250 to here, how many degrees is this one? Okay, it's 180 to here, and then whatever we have to add to get 250, we're going to put right there. So that's a 70 degree angle. That ends up being my reference triangle there, or reference angle. So I do all my math for that triangle, and it applies to the 250 degree angle. So if I wanted to know the tangent of 250, I could find the tangent of my 70 degrees right here and get the same answer. The only difference is when you plug in the tangent of 250 in your calculator, it's going to figure out whether it's positive or negative. When you're doing it by hand like this, you're going to have to make that determination, because tangent is opposite over adjacent. Well, this opposite here, which is right here, it's my y value, is going to be negative, isn't it? So whatever y is, or whatever my opposite is from this angle here, is going to be negative. So I need to remember that. That's going to be negative. Where'd my pen go? Over my adjacent, and my adjacent is right here, and it's also negative. So negative over negative is a positive. So my answer in the third quadrant is going to be positive, and this is where your all students take calculus come from. Tangent in the third quadrant is positive, just like I said. Alright, so if, let's get rid of a bunch of this stuff. I just scribble everywhere, and then I hope you can follow with what I'm doing with all my writing. If we're over here, I've got an angle there, and let's say that angle is a 320 degree angle. Well, what's the degree of this one? Well, whatever 360, because if we went all the way around, it would be 360. So we just went to 320, so what does it take to get to 360? It takes 40. So that's a 40 degree angle. That's my reference angle. So I do all the math for that one triangle, and it gives me the answers as if it were a 320 degree angle. This is where students get so confused, is they can never remember what this angle is right here. Do I draw this for my triangle, or do I draw this to my triangle? You always, always, always connect it to the x-axis. You never, ever, ever connect it to the y-axis. So if we have an angle here, it's going to connect there. If we have an angle there, it's going to connect there. It never connects to the y-axis. If it does, you're going to get the wrong answer. And in fact, you won't even be able to do it because your angles and everything else won't be there. And you're like, what the heck's going on? I don't even know what to do. And then you'll text me to ask me why, and I'll say, look at what you're attaching, your vertical line. You're making it a horizontal line and attaching it to y. Don't do that. Okay, so example 1 says, find the reference angle for each angle. Well, we've got a 218 degree angle. It's going to be over here somewhere. Draw our line. What is this angle? 218 to there. Well, I know this is 180. So how did I get here? I added another 38 degrees. So my reference angle is 38 degrees there. If I have something really psycho like B that says we have a 1,387 degree angle, so we're here and we're going around 360, 720, all the way around and around and around until we get the right angle. The best way that I found to do this is to take 1387 minus 360 and keep taking 360 away from it until you get a number less than 360. So we're just going to keep doing that, and pretty soon we get a number, once we get done, of 307. It's like, okay, cool, I get an angle of 307. I can do that. 307. There's 270. 307 is about right there. Draw my triangle there, and whatever this is between 360 and 307, to get from here up to here is going to be, let's see, 307, 360, 53 degrees will be this angle right here to get me up to 360. Okay, so that's example 1. Holy smokes, 8 minutes just to get through example 1.